Hello everyone, how are you doing? I trust you are all doing great and you are ready for the festive season. James from JTS Maths Tutoring here. Today I'm continuing at looking at proving the inverse of a 2 by 2 matrix with the entries A, B, C, D using the matrix inverse definition. So what does the matrix inverse definition say? It states that if A is a square matrix and it is invertible, then there exists a matrix A to the power -1, which is called the inverse of A, such that A multiplied by its inverse or vice versa, it is going to give us an identity matrix. So which means I can straight away multiply this given matrix with the given inverse to prove if it is going to give me an identity matrix, which is what I've already done in my previous video. So this time around, I'm assuming that the given inverse is equal to this 2 by 2 matrix with the entries X, Y, Z. So by definition, I know that A multiplied by its inverse is supposed to give me an identity matrix. So this is exactly what you see, what I have right here. So by matrix equality, I know that AW plus BY is equals to 1, AX plus BZ is equals to 0, CW plus DY is equal to 0, and CX plus DZ is equals to 1. So I've created those equations. So let us solve them. Is equal to minus dy over C. I'm going to sub in that value for W into my first equation. So this is going to give me A into minus dy over C plus BY is equals to 1. This implies that negative ADY plus CBY is equal to C. This implies that negative Y into AD minus BC is equals to C. This implies that Y is equals to negative C over AD minus BC, provided AD minus BC is not equal to 0. Awesome stuff. Now I can plug in that value for Y into this third equation here to get my value for W. This C is going to cancel that C, and this negative sign is going to cancel that negative sign. So W is going to be equal to D over AD minus BC. Awesome stuff. I can do the very same thing to get the remaining variables. From the C, substituting that value for X into the fourth equation gives me C into minus BZ over A plus DZ is equals to 1. This implies that minus CBZ plus ADZ is equals to A. This implies that Z into AD minus BC is going to be equal to A. This implies that Z is equals to A over AD minus BC, where we already know that this denominator must be equal to 0. Now we can get the value for X. These two A's, they're going to cancel each other, which is going to give me minus B over AD minus BC. All right. So I'm just going to plug in the values for W, X, Y, and Z, which is going to give me what I have right here. Now I can see 1 over AD minus BC is a common factor, so I'm going to factor it out. Did you see that, Jimmy? I've actually proved that if A is invertible, then its inverse is what we are given right here. All right, guys, allow me to do what Mama taught me. A good visitor knows when to leave, or a good dancer knows when to leave the dance floor. Till we meet again, be rest assured that at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Till then, don't do what Mama and I wouldn't do. Adios, amigas and amigos.